You know, every single time you check your bank balance, or book a flight, or even just scroll through your favorite online store, you're talking to this huge, invisible system. It's kind of the silent engine of our entire digital world, and it's called a database management system, or DBMS. So today, we're going to pull back the curtain on this incredible technology. But to really get a feel for this, let's do a little time travel. Picture it. You're running a university back in, say, in the 1960s. You've got records for students, instructors, courses, grades, all of it. How in the world do you keep all that organized and accessible with just basic computer files? Well, as you can probably guess, you don't. It was an absolute recipe for chaos.
So here's our game plan. First, we're going to look at that data chaos, the old way of doing things. Then, we'll introduce the hero of our story, the DBMS. We'll check out how it organizes all that mess, how we actually talk to it, and finally, why this one invention quietly runs pretty much everything.
Right, so before the DBMS came along, organizations stored all their info in what's called a file processing system. All that really means is that data lived in a bunch of separate files, and each one had its own special little program built just to read and write to it. And here's where the problems start. Just imagine you've got a student who's double majoring in music and math. Their info, like their address, ends up in two totally separate files. Now, what happens when they move? Someone has to remember to update their address in two different places. And if they forget one, boom, your data is now inconsistent. That problem is called data redundancy, and it was a massive headache. And that one little issue, that was just the tip of the iceberg. I mean, this old system was just riddled with problems. If you needed a new report, like show me all the students in a certain zip code, you couldn't just ask. A programmer had to write a whole new application just for that one question. Data was totally isolated, and enforcing simple rules, like making sure an account balance never goes below zero, was next to impossible. And then you had these things called atomicity problems. Think about a simple bank transfer, right? Two things have to happen. Money leaves one account, and it gets deposited into another. What if the system crashes right after the withdrawal, but before the deposit? That money just vanishes. The whole transaction has to happen, or none of it can. And these old systems just couldn't guarantee that. They were fragile, inefficient, and honestly, dangerously insecure. So how do you fix this digital mess? Well, computer scientists came up with a truly revolutionary solution, the database management system. And this wasn't just some small improvement, it was a complete and total paradigm shift in how we handle information. So what is it exactly? Well, a DBMS is really two things in one. First, it's a centralized collection of all your data, all linked together. That's the database itself. And second, it's a powerful set of programs that acts like a gatekeeper, giving you a super convenient and efficient way to store, get, and manage all that data. And the beautiful thing is how the DBMS directly solves every single one of the problems we just talked about. By putting all the data in one place, it gets rid of redundancy. So our double major student's address, it's now in just one spot. It gives you tools to get data efficiently, so you don't need a new program for every question. It enforces those integrity rules, it guarantees that transactions are atomic, all or nothing, and it manages a ton of people using it at once without causing errors. And, this is a big one, it provides real security, controlling exactly who gets to see and change what. Okay, so this all sounds fantastic. But how does a DBMS actually pull this off? Well, it all comes down to a really clever way of organizing the data and, more importantly, how it shows that data to us. It works using layers, kind of like a cake. At the very bottom, you have the physical level. This is all the super complex, messy details of how ones and zeros are actually laid out on a disk. And thankfully, we almost never have to see this level. The magic happens in the middle, the logical level. This is where the database organizes everything into simple, easy-to-understand structures, totally separate from the physical mess. And this separation is the key. It means you can change how things are stored physically without breaking everything. And then, right at the top, you have the view level, which gives each user their own little custom window into the database. A payroll clerk sees salaries, but they don't see student grades. Everybody sees only what they need to see. So how do we usually build that logical level? Well, the winning idea, the one that is still by far the most popular today, is the relational model. And its core concept is incredibly simple. Organize everything into tables. Yeah, that's it. Just think of a spreadsheet. In the database world, these tables are just formally called relations. And since we're diving in, let's learn a little bit of the lingo. In the relational model, you'll hear the pros talk about tuples instead of rows and attributes instead of columns. It's just the formal terminology, but it's good to know. A tuple is basically one whole record, and an attribute is one piece of info about that record. This table, or relation, right here is a perfect example. We're looking at the instructor relation. Each tuple, or row, represents one single instructor. And each attribute, or column, holds a specific piece of information about them, like their ID, name, or salary. It's clean, it's structured, and it's really easy to understand. So we've got our data all neatly organized into these tables. The next big question is, how do we actually get information out of them? We need a way to ask the database questions. We need a language. And that language is SQL, which stands for Structured Query Language. And its secret weapon is this one really simple, powerful idea. It's declarative. What that means is you don't tell the database how to find something. You just tell it what you want. You declare your goal, and the DBMS, like a brilliant assistant, figures out the fastest, most efficient way to go get it for you. Let me put it this way. A procedural language is like giving someone turn-by-turn directions to get to the store. A declarative language, like SQL, is like just telling your GPS, take me to the store. You just state your destination, and the system handles all the complex how for you. This makes asking really powerful questions surprisingly simple. Now, this might look like intimidating code, but let's just read it like a sentence. It's basically saying, select the sailor's name from two tables, one called sailors and another called reserves, where the sailor's ID is the same in both tables, and the boat's ID is 103. And all that fancy talk just means find the names of all the sailors who reserved boat 103. It's an incredibly precise and powerful question asked in just a few simple words. So let's bring this all together. We've gone on a journey from total chaos and separate files to neatly organized tables that we can actually talk to using SQL. So why does any of this technical stuff matter? Well, because this transformation is what makes our entire modern world tick. I mean, think about it. The banking systems that manage trillions of dollars in transactions, that's a DBMS. Airline reservation systems that coordinate millions of passengers and thousands of flights all at once, a DBMS. Those university systems that finally replaced all those old chaotic files, you guessed it, a DBMS. Every single time you buy something online, track an order, or even see a personalized recommendation, a database is working its magic behind the scenes. So what started as a solution to a pretty simple problem of inconsistent, isolated data files, well, it evolved into the foundational technology for our entire global economy. This move from chaos to order, powered by the DBMS, quite literally built the digital world that we all live in today. And so we've seen how this amazing technology brings order and structure to information. We've established that our whole digital world, from our money to our education, it all runs on these systems. The technology gives us the structure and the access. But this leaves us with a much bigger, more human question to think about. Who gets to control all of the powerful, personal, and vital data that's stored inside them?